Deterring garbage and pollution, strategies, technologies, and enforcement mechanisms in 2025. In an era where environmental degradation poses existential threats to ecosystems, human health, and global economies, the battle against garbage and pollution has never been more critical. As of September 15, 2025, the world generates over 2.5 billion tons of waste annually, with plastic pollution alone choking oceans and landfills overflowing in urban centers. Garbage dumping and pollution, encompassing illegal waste disposal, industrial emissions, chemical runoff, and littering, not only contaminate soil, water, and air but also exacerbate climate change through methane releases from landfills. Deterring these issues requires a multifaceted approach: preventive measures to reduce waste generation, robust enforcement to penalize offenders, and innovative technologies to monitor and track violations. This essay explores traditional and modern methods to deter garbage and pollution, with a focus on cutting-edge technologies for identifying and sanctioning perpetrators. By integrating education, policy, infrastructure, and digital tools, societies can foster sustainable behaviors and hold polluters accountable, paving the way for a cleaner planet. Traditional methods to deter garbage and pollution. Historically, deterrence has relied on regulatory frameworks, community engagement, and physical infrastructure to prevent pollution at its source. Governments worldwide enforce laws like the U.S. Resource Conservation and Recovery Act or the European Union's Waste Framework Directive, which mandate proper waste disposal and impose fines for violations. For instance, signage at high-risk sites warns potential dumpers of penalties, while physical barriers such as fences or locked gates restrict access to vulnerable areas like vacant lots or nature reserves. Regular maintenance, including mowing and cleanup of chronic dumping spots, discourages accumulation by making sites less appealing for illegal activities. Education plays a pivotal role in behavioral change. Public awareness campaigns, school programs, and community workshops highlight the environmental and health impacts of pollution, encouraging habits like recycling and composting. In Delaware, for example, initiatives promote green purchases, food waste reduction, and wastewater management to minimize household contributions to landfills. Incentives such as deposit return schemes for bottles and cans reward recycling, while bans on single-use plastics in cities like San Francisco have significantly cut litter. Community involvement, through volunteer cleanups or neighborhood watch programs, fosters ownership and peer pressure against dumping. Infrastructure improvements are equally vital. Increasing the availability of trash bins, recycling centers, and composting facilities makes proper disposal convenient, reducing excuses for littering. In urban areas, well-lit public spaces deter nighttime dumping, as visibility increases the perceived risk of detection. These methods, while effective, often fall short in enforcement due to limited resources, prompting the integration of modern technologies for enhanced deterrence and accountability. Innovative approaches and economic incentives. Beyond basics, innovative strategies leverage circular economy principles to reduce waste generation. The United Nations Environment Programme, UNEP, advocates for combating food waste through better supply chain management, textile recycling to curb fast fashion pollution, and e-waste programs that promote repair over disposal. In 2025, smart waste management technologies optimize collection routes using data analytics, preventing overflow and illegal dumping. For broader pollution, carbon pricing mechanisms like taxes or cap-and-trade systems incentivize industries to adopt cleaner technologies, reducing emissions from factories and vehicles. Economic incentives further deter violations. Subsidies for eco-friendly alternatives, such as biodegradable packaging, lower barriers to sustainable practices. Conversely, penalties escalate for repeat offenders, including cleanup costs and business shutdowns. In the U.S., safety valve policies combine standards with pricing to cap pollution while controlling economic impacts. Public-private partnerships, like those modernizing waste collection in developing nations, reclaim materials through advanced recycling, turning waste into resources and diminishing landfill reliance. These approaches shift the paradigm from reactive cleanup to proactive prevention, but effective enforcement hinges on tracking offenders. The role of modern technology in deterrence. Advancements in 2025 have revolutionized pollution deterrence through smart, data-driven systems. Internet of Things, IoT, sensors in smart bins monitor fill levels in real time, alerting authorities to overflows that might lead to dumping. AI-powered apps engage citizens by providing recycling information and reporting tools, as seen in U.S. cities where interactive platforms gather feedback on waste management. For industrial pollution, AI analyzes satellite imagery to detect unauthorized emissions or deforestation, enabling preemptive interventions. Drones equipped with cameras and sensors patrol remote areas, identifying illegal dump sites with high accuracy. In Europe, AI systems maintain air and water quality by processing sensor data for anomalies, triggering alerts. Blockchain technology ensures traceability in supply chains, preventing pollution from unregulated sources like e-waste. These tools not only deter through visibility but also educate via apps that gamify waste reduction, rewarding users for sustainable actions. Tracking offenders with cutting-edge technologies. To penalize polluters, accurate tracking is essential, and 2025 technologies excel here. AI-enhanced surveillance cameras, like those in Baltimore, offer clear night vision and license plate recognition to identify dumpers. Radar detectors integrated with PTZ, pan-tilt-zoom, cameras monitor chronic sites, capturing evidence without constant human oversight. In Louisiana, renewed efforts use AI to track illegal dumping in real time, aiding swift responses. Satellite imagery, powered by AI, detects illegal landfills with over 90% accuracy, as demonstrated in recent systems analyzing vast areas for waste anomalies. Mobile surveillance units from companies like LVT provide live feeds and evidence for fines, deterring through deterrence and documentation. The Waste Watch Cam uses AI to spot littering behaviors, capturing footage for enforcement. Sensor-activated cameras in reserves detect motion and record violations, while intelligent video systems with object detection reconstruct crime scenes. AI also monitors compliance via permit tracking, flagging violations automatically. For broader environmental crimes, machine learning assesses risks and enhances inspections, as in EPA's hazardous waste detection models. These technologies balance security with privacy through anonymized data and focused deployment. Penalizing offenders, from detection to justice. Once tracked, penalizing offenders involves graduated sanctions. Fines, starting at hundreds to thousands of dollars, escalate for repeats, often including cleanup costs. In the U.S., EPA uses AI inventories for trustworthy enforcement. Criminal charges apply for severe cases, like industrial dumping, with jail time possible. Case studies illustrate efficacy. In the UK, EnviroCam AI detects fly tipping, leading to prosecutions via video evidence. Texas's TREGA framework regulates AI and enforcement, ensuring fair penalties from 2026. Globally, digital innovations have cut emissions by up to 20% through better compliance. In Italy, satellite monitoring reduced nitrogen dioxide, aiding pollution fines. Conclusion. Deterring garbage and pollution demands a synergy of traditional methods, like education and infrastructure, with modern technologies such as AI surveillance, satellites, and sensors. By tracking offenders efficiently and enforcing penalties rigorously, These tools not only punish but prevent future violations. As 2025 advancements continue, integrating ethical AI and global cooperation will be key to sustainable progress. Ultimately, a cleaner world hinges on collective action, where technology empowers enforcement and fosters environmental stewardship for generations to come.